Panthers, good morning. I'm sorry that I'm not with you today. I'm attending to some personal business out of town, but the learning will commence. Okay, you have already taken today a mastery assessment. I hope that went well for you. I will have that graded for you and have some feedback for you before the next time we meet on Tuesday. Panthers, our objective today, it says learners will be able to use the distributive property to simplify algebraic expressions. Okay, Panthers, this is the distributive property, and I know that you've seen this property before, but we're going to make sure with the time we've got today that you can perform this task very well. The distributive property simply says for any real numbers or variables, that's an important distinction there, numbers or variables, A, B, and C, the product A times the quantity B plus C simply is A times B, which, in high school algebra, we usually don't write A times B with the symbol between there. We usually just say AB. You could write A times B with the symbol in there. AB plus A times C. Or in other words, this number or variable in place of A gets multiplied by both of those numbers or variables B and C. We sometimes will mark this or show it this way. Sometimes you'll see me, in the future, you'll see me mark it this way. I'll say that this thing here, A, applies as a product to both B and to C. And Panthers, it works the very same way if the sign separating those two numbers is a negative. It's simply just A times the quantity B minus C. Well, if I distribute that A and multiply both terms by it, I'll get A times B minus whatever A times C is. Now, Panthers, since I know you've seen this before, I want to take a couple minutes of our time this morning and talk about why the distributive property works. All right, Panthers, on this slide you see it say multiplication is modeled very well by an area model. And I want to give you what I call a grade school example. Because this is something that you may have learned in grade school, doesn't mean that it's not something you can use as a 9th or 10th grade algebra student. It just works, okay? I actually remember my stepson Alex, who is actually sitting right here by me as I record the video this afternoon, doing problems like this when he was in 4th grade math. 63 times 4 could be written in this way. You could write 63 as a sum of 60 and 3. So the way that this often is modeled early on in, like, maybe 3rd grade, probably 4th grade, almost certainly 5th grade, is that you think about multiplication here, where you've got a sum of two things times one thing. So we'll model that with a little, what we call an area model. If I'm multiplying a sum of two things by a sum of one thing, I'll use a little grid or a rectangle or a set of blocks here that's two things long and one thing wide. And what we'll do is we'll put the one thing, the 4, right here. And we'll put the sum of the two things where it kind of fits, where it kind of makes sense, 60 and 3. This is a way that some students learn to multiply in a way that's probably quicker than if you did it the old-fashioned way. So you can simply multiply each corresponding set of items on the length with items on the width. 60 times 4 is 240. And 3 times 4 is 12. And what I remember Alex doing, and Adeline, who's in 3rd grade now and also sitting by me, will probably do this soon. Once you find those products, you can add them together to get the total product. The sum of 240 and 12 is 252. So you may not have experienced multiplying this way, but this way works, and a lot of our younger students are learning to do this, and this way of thinking really helps explain why the distributive property works. So Panthers, and this is the last slide that I think is on your first page of the handout, what we said here simply is that think about being able to tear that area model into pieces. And I'll model the same one that we just did previously here. 63 times 4 is simply 60 plus 3, the whole thing times 4. So if I think about that area model, and I'll draw this one out a little bit more quickly this time, I could think about multiplying 63 times 4 by putting the 4 here and calling the top here like 60 plus 3. And then we said, okay, well, that means 60 times 4 was 240. Still means that 3 times 4 was 12. And this concept of doing the whole multiplication together, let me draw something else. And I'll draw it, and then I will let you pause. And we will pause the video for a second. There it is, Panthers. We're going to pause the video in a second, but what we want you to think about while you are paused is this. Is there anything different on top compared to what I did on bottom? We're going to pause the video and you talk at your tables for a minute. All right, welcome back, Panthers. Ultimately, I hope you decided at your table that there's not really any difference between what we did on top and what we're doing here on bottom. They both give the same two products. You can just kind of tear that 63 in half. In other words, 4 times 63 is going to give me whatever 4 times 60 is, plus whatever 4 times 3 is. And this is just demonstrating that distributive property. I'll do one more here, and we don't even necessarily need to tear this one. We'll kind of model the same thinking here. If I need to multiply 5 by x plus 2, let's use a 1 by 2 grid, a 1 by 2 rectangle. We'll put the one thing here, and we'll put the sum of two things here, x plus 2. And let's simply multiply each corresponding part of the problem together. Here, for this box here, 5 times x is simply 5x, Panthers. I don't know what number x is standing for. If I did, I could multiply that number by 5 to get this number. 5 times 2 is 5 times 2, which is 10. And I need to think about that plus sign being between it. So by being able to tear apart our area model, I can see that 5 times x plus 2 is simply 5 times x plus 10. And that's the distributive property you know, isn't it, Panthers? All right, Panthers, let's get down to brass tacks now. We don't need to make that area model every time we distribute, but if it helps you, you're welcome to do it. Panthers, I'm going to simplify. This is on the back page of the front of your handout, or this is on the back of the first page of your handout. We're going to simplify this with the distributive property. We need 3 times the quantity n plus 7. I do kind of model that distributive property this way. So I'm going to remember that 3 times n is 3n. I'm going to remember that 3 times 7 is 21. And this plus sign here should come through as well. 3 times n plus 7 is 3n, 3 times n, plus 21. Panthers, there's a very common student mistake that sometimes happens when the number we're distributing is a negative number. And you probably already know what it is. But let me show you what happens here. If I multiply both x and 3 by negative 4, I'm going to get negative 4 times x, which is simply negative 4x, negative 4 times x. And negative 4 times positive 3 is a negative 12. Do you know what that common mistake is? It's been my experience, Panthers, that students, when they're distributing a negative number or a negative variable expression, often forget the negative sign on that second term, or really any term that comes after the first term. So be very careful, Panthers. Okay. Just like we often do when I'm physically with you, Panthers, the next 2 are for you to try. Try it on your own before you check in with your neighbors. We're going to pause the video for about 2.5 minutes. Get the answers you think are best, and in about 2.5 minutes' time, we will hit play and we will check it out. All right, Panthers, you've had a chance now to try these 2. Let's see how you did. We need 5 times the quantity 6 minus a. If I distribute that, I need 5 times 6. 5 times 6 is 30. 5 times a is 5a, and I need to keep this negative sign the same. It's negative 5a. So how about an answer of like 30 minus 5a? Looks pretty good to me. B, Panthers, was your chance to make a common mistake again, and I hope you avoided it. And if you didn't, that's okay. we need to multiply negative 2 by both of these things. Negative 2 times x is simply negative 2x. Negative 2 times a negative 10, I hope you remember, Panthers, that if you multiply two negative numbers together, you get a positive product. Negative 2 times negative 10 is positive 20. And we should get an answer like negative 2x plus 20. How'd you do? All right, Panthers, I'll do 2 more, and I'll ask you to try 2 more, and then you'll be ready to practice on your own. Panthers, here we need to multiply 7 by 3 times x, and also 7 times the negative 2. 7 times 3x is like taking 3x and multiplying it, by adding 7 3x's together. And if you added 7 3x's together, you would get 21x. And 7 times the negative 2 is going to be negative 14. So we've got 21x minus 14. Panthers, on B, I need to multiply negative 3 by both 7 and also 4n. Negative 3 times 4n would be negative 12n. Negative 3 times positive 7 would be negative 21. How about a final answer like negative 12n minus 21? All right, Panthers, you know what time it is again. These 2 are for you. We're going to pause the video again for 2.5 minutes. You try both items. Check in with your neighbors when you've got answers you like. And in 2.5 minutes, we will hit play and we'll check it out. Good luck. How'd you do, Panthers? Let's check it out. If I need to multiply negative 9 by both negative 3 and positive 4a, negative 9 times negative 3, again, 2 negatives multiplied together makes a positive product. I get positive 27. For the first term in an expression, I don't need to put a plus sign out front. In fact, it's probably better if I don't. Negative 9 times positive 4a would give me negative 36a. We've got that one done. What's different on B, Panthers? That's right, good job. The number we're distributing through here is on the right side, but Panthers, that property still works. If I need to multiply 6 by negative 5x minus 3, I'll simply multiply each term by 6. 6 times the negative 5x would make negative 30x. 6 times negative 3 would make negative 18. And I've got an answer like negative 30x minus 18. Okay, Panthers, it's time for you to practice now. There is an activity on the second page of your handout. The front page has some practice problems. You should be working on those. The back page has a maze, and I'd like you to see how many of those you can work as well. Panthers, I'll miss you today. Have a good weekend. Be safe, and I'll see you bright and early Tuesday morning. Have a great day, Panthers.